Let us consider a plant where during its operation, due to a poor design during the construction phase, natural gas during operation is vented into the utility room of the plant itself. Eventually, the gas accumulates, and, upon finding an ignition source, it ignites and results in a massive explosion. During commissioning, safety aspects are overlooked. This always has catastrophic consequences. Safety aspect with storage tanks. One of the key aspects of pre-commissioning is the readiness of mechanical equipment. We shall focus on the safety aspects of the mechanical completion, with respect to storage tanks, and the piping system. Check if material test certificates are available. Check if the roof has minimal welding. Has the weld joint efficiency been ascertained? Have external and internal inspections been carried out? Check if non-destructive tests, like the following, have been carried out: water fill test, magnetic particle test, dye penetration test, radiography test. Confirm that hydrostatic tests have been carried out as per applicable standards. Check the availability and functioning of backflow check valves, emergency shut-off valves, and pressure relief valves. Check the availability of earthing bars. Check if the tanks have been cleaned before putting them into service. Confirm purge with inert gas when necessary. Check for contaminants such as rust, water, and debris. Case study. A world-renowned refinery in the U.S. suffered a disaster during the commissioning of one of its units. During the commissioning of a raffinate splitter tower, operations personnel pumped flammable liquid hydrocarbons into the tower for over 3 hours without any liquid being removed, which was contrary to start-up procedures. Critical alarms and control instrumentation provided false indications that failed to alert the operators of the high level in the tower. Consequently, unknown to the operations crew, the 52 meters tall tower was overfilled and liquid overflowed into the overhead pipe at the top of the tower. The overhead pipe ran down the side of the tower to pressure relief valves, located 148 feet, or 45 meters below. As the pipe filled with liquid, the pressure at the bottom rose rapidly, from about 21 pounds per square inch to about 64 pounds per square inch. The 3 pressure relief valves opened for 6 minutes, discharging a large quantity of flammable liquid to a blow-down drum, with a vent stack open to the atmosphere. The blow-down drum and stack overfilled with flammable liquid, which led to a geyser-like release out the 34 meters tall stack. The blow-down drum was not connected to a flare system to safely contain liquids and combust flammable vapors released from the process. The released volatile liquid evaporated as it fell to the ground and formed a flammable vapor cloud. The most likely source of ignition for the vapor cloud was backfire from an idling diesel pickup truck, located about 7.6 meters from the blow-down drum. As a result, the 15 employees killed in the explosion were contractors working in and around temporary trailers. Houses were damaged as far away as 3/4 of a mile from the refinery. Issues and challenges. Commissioning was authorized in spite of pending work. Start-up procedures were incomplete. Inadequate resources for the commissioning activity. Operator training program was inadequate. Key alarms and level transmitter were not inspected prior to commissioning. Questions to be posed. Could this have been avoided? List out some of the possible solutions that could have prevented this disaster. Solutions. Pre-commissioning safety checks to ensure risk analysis associated with the process has been carried out. All instruments are available, and their functionality has been proven. Training has been provided. Adequate resources are available for commissioning.